If you're wondering what to sunset, not just what to add, you're in the right mindset. Welcome to AI on AI, where expert AIs debate the messy reality behind shiny benchmarks. Today we're asking, are frontier multimodal models truly ready for healthcare, or are we fooling ourselves?
Yeah, look, recent models crush medical leaderboards, but stress tests show they still guess right for the wrong reasons. When you yank the image, many answers stay correct, which is not multimodal understanding.
And strategically, that's a classic false positive for readiness. Enterprises see high scores, then hit brittleness in deployment, like answer flips when options are reordered or distractors get tweaked.
Technically, we're seeing shortcut learning. It's like trying to diagnose pneumonia by keyword bingo, not by reading the film. Good input, good output fails when the model only sees surface cues.
Right, and the wild part is, asking for step-by-step reasoning sometimes makes accuracy worse. You get beautifully fluent, confidently wrong logic. It's like debugging spaghetti code in the dark.
From a governance angle, new regional AI rules emphasize transparency and risk management, and this brittleness hits both. You need audit trails that show why an answer changed when the image changed.
Quick example, swap an image to match a distractor, keep the text the same. Lots of models follow the new picture confidently, even when the text contradicts. Visual label pairing beats real integration.
In practice, that's dangerous. A dermatology case with a classic rash shouldn't be solved from text alone, yet many systems still pick the diagnosis without seeing the image, then fabricate heliotrope in the rationale.
So the headline is, Leaderboard wins can hide fragility. What's the more robust bar for healthcare readiness?
Stress testing needs to be first class. Remove modalities, reorder options, weaken distractors, and introduce counterfactual images. If performance swings wildly, you're measuring test taking, not medicine.
Business translation: treat benchmarks as diagnostic instruments, not goals. Report disaggregated performance by reasoning and visual complexity, not a single average that masks risks.
A heuristic I use triage by perturbation. If a trivial prompt change flips the answer, the model's brittle. You can score high and still be untrustworthy under real clinical uncertainty.
We piloted a refusal on missing evidence policy. Some models that abstain when the image is absent look worse on paper, but better on patient safety. Accuracy below chance can be the right behavior.
That's the contrarian take I'll defend. Conservative abstention aligns with risk frameworks and upcoming adaptive model guidance, especially for high-stakes imaging and pathology.
Counterpoint, though, over-refusal kills throughput. The trick is conditional abstention with escalation. Agents that request the missing modality or route to a human fail fast, learn faster.
Real-world example, chest X-ray report generation. Even when summary scores look strong, clinically meaningful findings drift under small visual noise, so radiologists need flagged uncertainty and evidence pointers.
What about reasoning quality? Are explanations salvageable?
We found 3 failure modes: confident but false heuristic, hallucinated perception, and thinking with image but misgrounded. The steps look neat but don't anchor to the right features.
Practically, enterprises should ban free-form rationales in production unless they're provenance grounded, tie claims to crop coordinates or text spans, or don't show them.
Quote to remember, interpretability isn't a performance boost, it's an honesty test. If the rationale and evidence don't line up, treat the answer as suspect.
On benchmarks, there's heterogeneity no-body documents. One dataset is mostly text-solvable. Another demands subtle visual cues. Treating them as interchangeable is like mixing apples and MRIs.
We built a rubric for reasoning and visual complexity: clinical context, uncertainty handling, spatial importance, multi-view alignment, report along axes, not just a leaderboard rank.
Recent multimodal releases tout agentic workflows. Great, but agents inherit shortcut habits from base models. Stress tests should be part of the agent's pre-flight checklist.
Humor break: if your model sees purple eyelids in a paragraph without an image, it's not diagnostically gifted, it's reading fan fiction.
to expert interactions incoming, pushback time.
I'm skeptical that robustness scores alone drive adoption. Leaders still chase velocity, not variance, because the ROI narrative values throughput.
I get it, but new liability models price variance. Reliability beats raw speed when auditability becomes mandatory, even if throughput dips.
Building on that, variance tax is avoidable if you run layered defenses, abstention policies, adjudication agents, and adversarial prompts in shadow mode before go-live.
And staggered rollout. Start with assistive triage or QA audits, not autonomous diagnosis. Collect real-world drift, tune, then expand scope. Training wheels first.
Use case emergency department triage. The model proposes likely studies, flags missing modalities, and justifies via linked findings. Humans accept or modify, and the system learns robustly.
Another, dermatology referral management. The system clusters cases by visual similarity, but humans label edge cases. Retrieval beats raw generation when visuals are subtle.
Let's talk recent developments. What's moved the needle in the last few months?
Frontier models added better voice, vision stacks, and faster tool use. Yet the same stress tests show brittleness under option shuffles and distractor changes.
Also, a big platform pivoted to agents everywhere for enterprise workflows, promising, but governance and test harnesses lag, especially in healthcare.
Regulators tightened expectations around dataset provenance, post-deployment monitoring, and change logs for adaptive models. That's going to force stress test reporting in release notes.
On the open side, New Vision language systems improved report generation metrics. Still, human audits reveal omission errors on subtle findings. Numbers don't catch clinical nuance.
Strategy heuristic. Benchmarks are speedometers, stress tests are brakes. You need both to drive safely in healthcare.
Implementation tip. Build a counterfactual gallery. For any correct answer, swap the image to support a distractor and ensure the model flips with evidence, not with vibes.
And measure refusal quality. Appropriate I don't know is a feature, not a bug, better to hedge than hallucinate.
Predictions. What changes next year?
Robustness scoring will become standard, with modality ablations and adversarial perturbations baked into evaluation suites.
Procurement will demand variance reports and abstention policies. Show me your worst case becomes a buying criterion.
Agents will shift from single-shot answers to multi-step evidence gathering. Think inspect, retrieve, align, not guess and gloss.
Tooling will move toward grounded rationales, coordinates, crops, and linked sources, reducing pretty but misleading explanations.
Compliance teams will require drift dashboards and rollback plans for adaptive models. Auditability beats glamour.
Technically, multimodal fusion will get sturdier with cross-attention gates and counterfactual training. Less label pairing, more true integration.
Clinically, rollout will emphasize assistive workflows where humans stay in the loop. Safe augmentation before automation becomes the guiding phrase.
Takeaway: don't mistake exam tricks for medical understanding. Stress test, ground your evidence, and deploy where uncertainty is managed, not ignored. Don't miss the brief summary right after this.
Narrated by the AI voice of Shri. The main theme is whether high medical benchmark scores show real readiness for healthcare use. A benchmark is a standardized test dataset used to measure model performance. Modality means the type of input, such as text, images, or both. Researchers stress tested 6 leading multimodal systems across 6 medical benchmarks. They found models often succeed for the wrong reasons, relying on shortcuts rather than medical understanding. Shortcut learning means exploiting superficial patterns instead of interpreting clinical evidence. Accuracy stayed surprisingly high even when images were removed from visual diagnostic tasks. On items that required images, several models scored around 37% without images, above the 20% random baseline. Removing images from the New England Journal of Medicine dataset caused drops up to 29 percentage points for one system. Removing images from the Journal of the American Medical Association dataset caused small changes, suggesting many items are solvable from text alone. A distractor is a wrong answer option designed to challenge the model. Reordering answer options reduced text-only accuracy by about 4 to 6 percentage points for multiple systems. Replacing all distractors with irrelevant options drove text-only performance toward random guessing. With both image and text, weakening distractors often increased accuracy toward 90%. Visual grounding means correctly linking image evidence to the answer. Replacing the original image with one matching, a distractor caused accuracy collapses over 30 percentage points for several models. Chain of thought prompting asks the model to reason step by step. Chain of thought often reduced accuracy on medical tasks, and explanations frequently describe features not present. One model frequently refused to answer when images were missing, scoring below chance, which may signal cautious behavior. Benchmarks differed widely in visual dependence and reasoning complexity, despite similar leaderboard scores. Researchers introduced 6 targeted stress tests to simulate missing inputs, format changes, and misleading images. Robustness means stable performance under small changes, incomplete data, or noisy inputs. Clinicians created a rubric to profile benchmarks by reasoning depth and visual demands. They found some datasets require high visual detail and complex inference, while others are mostly text solvable. Experts recommend treating benchmarks as diagnostic instruments rather than goals. They suggest reporting performance along medically meaningful dimensions, not only overall accuracy. Evaluation should include routine stress testing and metadata about reasoning and visual requirements. Key challenges include unreliable reasoning signals, overconfidence under uncertainty, and shortcut dependence. Open questions include how to measure genuine medical understanding and trustworthy visual interpretation. Future work should emphasize robustness, sound reasoning, and alignment with clinical context. This matters because healthcare deployment demands reliability, clear explanations, and safety under uncertainty, not just high scores. If you like what you heard, please share this podcast with someone who may benefit.